Video, I will solve problem 5. This is problem 5. It's about blood test for 100 people. There are two methods, method 1 and method 2. Method 1 is the normal method, which is test each person one by one. And so the total test and 100. If the method 2 divide 100 people into 10 groups with 10 people in each group, and then mix the blood in the group, and then we test the blood for the group. If the blood is negative, then everyone in that group is negative. If the result is positive, then we have to test all people in that group one by one. And then for that group, we need 11 tests. And we should know that for a person, the test result is positive, is equal to 0.1. And we assume each person is independent. So we consider because each person is independent, so we can consider each group individually first, and then for a group, the probability of negative is 1 minus 0.1 is in the exponent of 10. Which means that all people in that group are negative. And so because there are only two cases for a group which are negative and positive, so 1 minus the probability of negative is equal to the probability of positive. So for the expected test for each group is 11 times the probability of positive, because when in case of the positive, we need 11 tests, and plus 1 times probability of negative. If the result is negative, we only need 1 test. So we can calculate the value and then get this result for each group. So when we consider all groups, so it's 10 times the expected value, so we get this result. That's it for the problem 5. Sorry. Thank you. So for problem 5, it introduced a method for blood testing. Use this method 2. It reduced the times of tests about a quarter. It is a very good method which can reduce the total test time. In expectation. I think it's kind of related to the encoding or something. I believe there's a great potential for other applications by using these ideas.